Welcome to the next video of Section 5, Creating a Player. In the previous video, we've learned about environment physics. In this video, we'll learn how to create a player. The player character is a small, green, alien-looking creature that can be controlled and guided by the gamer through a level using many conventional platform game mechanics such as walking, jumping, and interacting. In the previous section, we built a white box prototype character to test physical interactions with the environment, but here we'll develop the player character in more depth. The image on screen will illustrate our character texture imported earlier in the section, representing all limbs and parts for the player. The player texture is called an atlas texture or sprite sheet, because it contains all frames or parts of a character in a single texture space. The problem with this texture as it stands is that when dragged and dropped from the project panel to the scene, it'll be added as a single self-contained sprite. This is because Unity recognizes all these sprite parts as a single sprite. Rather, these should be separated into distinct units. To divide the character texture into separate parts on a per-limb basis, we'll use Sprite Editor. To access this tool, select the character texture in the project panel. Then, from the Object Inspector, change the sprite mode from single to multiple. Then, click on Apply. Next, click on the Sprite Editor button to open the Sprite Editor tool, allowing you to cut apart the whole texture into specific slices. With the Sprite Editor tool, you can separate different parts of a texture into discrete and separate units. One method to achieve this is by drawing a rectangle around each image area that should be separate and simply clicking and dragging your mouse to draw a texture region. Now, although a sprite can be separated manually, as we've just seen, Unity can often cut apart the texture automatically, identifying isolated areas of pixels and saving us a lot of time. We'll do that here for the player character. To do this, click on the Slice button, listed at the top left corner of the Sprite Editor window. From the Slice tool window, ensure that Type is set to Automatic, which means that Unity will auto-detect the location of separate sprites. Pivot can be left at center, determining the pivot point for each sprite. Method should be Delete Existing, meaning that any existing sprites or slices in the texture space will be erased and replaced entirely by the new auto-generated slices. Then, click on the Slice button to confirm the operation, and the texture will be sliced into separate sprites with a clear border drawn around each sprite. The texture is now divided into several sprites: head, body, arm, and leg. The final character in scene will obviously have 2 arms and 2 legs, but these will be formed from duplicate sprites. The final process now is to set the pivot point for each sprite, the point around which the sprite will rotate. This will be important later to animate the character correctly, as we'll see. Let's start by setting the pivot for the head. Select the head sprite in the editor and then click and drag the pivot handle, blue circle, to reposition the sprite's center of rotation. Click and drag the handle to the bottom middle of the head, roughly where the head would connect to the neck. This makes sense because the head will rotate and hinge from around this point. As you move the pivot around, you should see the X and Y values change from the custom pivot field in the Sprite Properties dialog, shown in the bottom right-hand corner of the Sprite Editor window. Next, position the pivot for the arm, which should be at the shoulder joint where the arm connects to a torso. Then for the leg, which should be near the hip where the leg connects to a torso. And finally the torso itself, whose pivot should be at the hip joint. When completed, click on the Apply button to confirm changes, and then close the Sprite Editor. On returning to the main Unity interface, the appearance of the character texture will have changed in the project panel. Specifically, the character texture features a small arrow icon attached to the right-hand side. When you click this, the texture expands to review all these separate sprites in a row, which can be dragged and dropped individually to the scene. Now that we've isolated all player sprite textures, we can start to build a game character in the scene. Start by creating an empty game object with the game object createEmpty command from the application menu. Name the object player and assign it a player tag from the inspector. This object will act as the ultimate or topmost parent object for the player character. Existing beneath this object as children will be the character's constituent parts, torso, arms, and legs. So let's drag and drop the torso sprite from the project panel to the hierarchy panel as a child of the player object. After the torso has been added, we can add legs and arms. The arms should be added as children of the torso because the torso determines where the arms will be. However, the legs should be added as children of the player object and are therefore siblings of the torso, because the torso can rotate independently of the legs. As you add each limb, you'll want to offset its position so that it appears correctly in relation to other limbs. The head should appear above the feet and so on. The rendering of body parts is probably not correct by default insofar as each item will have an identical order in the sprite renderer component. This means that Unity could potentially render each limb in any order, allowing arms to appear in front of the head, legs to appear in front of the body, and so on. To correct this, we'll select each limb in turn and assign it an appropriate order value, taking care that it's higher than the world background order and less than the world foreground order. I've assigned the body an order of 103, the head 105, left arm 102, right arm 104, left leg 100, and right leg 101. The rendering order for limbs is now configured successfully. Let's set up collisions and physics for the player. To do this, add two colliders. A circle collider to approximate the character feet, allowing us to determine when the character is in contact with the ground. A box collider that approximates most of the body, including the head. These colliders can be added by selecting the player object, the topmost object, and then navigating to Component, Physics 2D, Circle Collider, and Component, Physics 2D, Box Collider 2D. The Circle Collider is of special importance because it's the primary means to determine whether the character is touching the ground, and it'll also be in contact with the ground as the character moves. For this reason, a physics material should be assigned to this collider to prevent friction effects from stopping or corrupting character motion as it moves through the scene. To achieve this, create a new physics material by right-clicking in the empty space in the project panel and choose Create Physics 2D Material from the context menu. Name the material Low Friction. Select the Physics 2D material in the project panel and, from the inspector, change the friction setting to 0.1. Then drag and drop the Physics 2D material from the project panel to the Materials slot for the Circle Collider 2D component on the player object. Using these settings, the character will behave more realistically. Then finally assign Rigid Body 2D to the player object and set both linear drag and gravity scale to 3. In addition, set collision detection to continuous for the most accurate collision detection, and freeze rotation of the object on the Z-axis because the player character should never rotate. Now you've fully completed the physical object representing the player. Good work! We've now successfully created a player. In the next video, we'll learn about scripting the player movement.